And to tell about myself, I'm a computer science engineer with a long history in automotive. So recently I switched to the clean tech, or I would say the maritime electric vehicle segment. So NSURE, we started our journey with smart meters. So we transformed and converted the analog based meters into a digital and IoT based smart meter, and then eventually we get into the LFP cell manufacturing, which was the need for the day. And NSURE is one of the privately held company to start the energy as well as the cell manufacturing business in India. So right now we are into the gigascale capacity. So we started with the pilot facility, which was about 5 megawatt, and then right now we are scaling to a couple of gigawatt our capacity. And then once we have the know-how of manufacturing the cells and building the pack, we got into the BESS, that means the battery-based energy storage system, so wherein we store the excess of solar energy and store it, and then use it when the power is on demand. And then we realized, okay, so we are into the power and energy sector, so why don't we get into some useful product? So after a lot of discussion, having coming from automotive, I know the challenges in being a startup getting into the market. So I thought, let us get into the maritime segment, which is having more potential, and then it is more polluted than the road as well as the other transport segment. And then also we developed a product which takes care of the battery backup, power bank, and these are our product lines, and I'm managing all these product lines. And with all these things put together, so we are in the process of becoming a company to get into the circular economy. So I don't have to talk much about circular economy, where the experts know many things about what is circular economy. And more than a circular economy, we are a vertically integrated company. So when I say vertically integrated, we manufacture the cells, we put it into a pack, we make as ESS, and then we develop mobility products, whether it is maritime or the road safety vehicles. And then also we transform and then monitor and monetize the energy in the form of meter, smart meter. So with our giga production, so we use the first life of the cell into the products. So that could be the BESS or the maritime, and then the second life goes into the inverter backup or the telecom backup, which is widely used in lead acid batteries. Now we are transitioning from the lead acid to the LFP based safe as well as the more efficient way of storing the power. And then finally we will retire the cell with recycling it, and then take the necessary part and bring it back to the manufacturing. So I would quickly talk about the interesting maritime project, which is specifically requested by Jan, my best friend and mentor, and then as well as the curator, Jose. So when we started, we didn't have any clue about how depth and how breadth of the sea. So when we want to develop a retro kit, we did a lot of market analysis, and the alarming factor is people are talking about the carbon credit, and then the greenhouse gas emission in the form of aviation, in the form of transportation vehicle. But the maritime is the biggest contributor in terms of millions of metric ton is contributed in the form of emission. So most of the ships, I would say 90% of the ships are driven by the diesel, and then some of them are hybrid. So no matter whatever the drivetrain, so the emission coming out of the ships, and then for the fishing boats, it's quite enormous. So as per the data, in 1960, the Indian Ocean, or I would say the Indian Peninsula, contributed 0.3 million metric ton of the CO2 emission. But in 2010, it got almost 4 times, quadrupled to 1.2 million ton. And then 2025 data probably I didn't have a look at it, or it's not yet available, but definitely it will be more than 3 to 3.5 metric ton of emission. So just think about how much emission is getting into the sea, and then that affects the ecosystem. So what we did is we used our own cells. We built the battery pack, we put the software, electronics. So thanks to my experience in the automotive sector, so it's not a big brainer to build a electric boat with the experience coming from the automotive. And then also we have used the similar motor and the drivetrain. So some modifications were made, and so on the right hand side you could see the product. It's proto. Now it is successfully running in the Bay of Bengal as well as in the Arabian Sea. So by mid of this year we are going to the series production. So we are in discussion with a couple of government agencies, wherein we could contribute the I would say not only the CO2, and also we could decarbonize, but at the same time the fuels saving. So in terms of just take an analogy of one boat, they consume roughly I would say 3,000 to 4,000 liters of diesel on a fishing day in a year. So usually the fisherman goes to 150 to 200 days a year. So for a single boat, the contribution and the expenses of maintaining and to bring a livelihood for them is then close to 1.5 lakhs to 2 lakhs. So with the help of these batteries, the cost could be reduced to 1/10. So for 100 rupees you charge, then you can bring down the cost from 1,000 to 100, which is really a magical number. So there is a social feasibility, there is an economic feasibility, and then with governance, so we could comply to the ESG. So a lot of people are talking about the ESG, but we are really getting into the economics of scale, and then social costs, and then also with proper governance. We are trying to decarbonize the maritime sector. So I'm looking forward to connect with someone who come from the maritime sector, who want to learn, share, and then grow together in the Indian maritime segment, especially on the electrification. You're welcome. And I'm on time. Thank you so much.